How's it going, everybody? My name is Rob. If you've never stopped here before, or this is your first time on this channel, I'd like to welcome you. I've received quite a few requests and pings, direct messages, whatnot, for people that are in the networking industry that wanted to know my take and my perspective on the new CCNA version 3 that is coming out here in the very near future. So I thought I would take a few minutes to break down my thoughts on the CCNA version 3 exam and some of the aspects to the exam that you may not be aware of. So for those of you that don't know me, my name is Rob. I am a CCIE in routing and switching. So I am quite familiar with all the topics that are on the blueprint for CCNA. And for those of you that are not aware as well, I'll put a bunch of links in the description so you will be easily able to navigate through things like this. I'm also an INE instructor, so I teach everything from CCNA through CCIE in various tracks for Internet Network Expert, and I'll put a link in the description for INE's website as well. So before we get into everything, the CCNA routing and switching exam on a typical basis gets refreshed every 3 to 4 years. I took and passed my CCNA routing and switching exam back in 2013, and I've had my CCNA for about 3 years. After I got CCNA, I moved directly into CCNP, and eventually then moved into CCIE and took and passed both the written and the lab. Now, when when people term CCNA, they typically term that as more of an entry-level certification. So you have some level of understanding, or you have maybe a help desk background, desktop support. Maybe you just want to break in the industry and you need a way to validate who you are. And that's exactly what I did when I first got in the industry about 5 years ago. That was something that I needed to have, depending on what you do and how you do it. Now, for those of you that are working in the contracting and consulting space, certifications carry a bit more weight in regards to validating who you are. In the enterprise space, I work for an enterprise corporation. Certifications don't carry as much weight in the enterprise, but they're a way for me to validate my skill sets and to basically show my minimum level of qualification for a potential position. That is why you would want to get certified, because then this is a way for you to basically make yourself shine a little bit better to the potential hiring manager that might be looking at bringing you on board. You have a skill set. If you pass CCNA, you don't get CCNA version 3. You don't get CCNA version 2. There's no versioning next to it. So a lot of questions I get about this are, if I've taken ICND 1 and ICND 2 is coming out, what should I go stop what I'm studying for ICND 2 right now and wait for the new version to come out, or should I just keep right on going? Keep right on going. If you are currently studying for a CCNA exam when it comes to routing and switching, don't stop what you're doing. Keep right on the track. Keep your, keep going. Don't stop. The thing here that needs to be really understood here is CCNA is actually a two-part exam. You have the ICND 1, which is I'll talk about that here in a moment, and then you have the ICND 2. ICND 1 is more your theory. What is a router? What is a switch? How do they work? What is the switching process? Why do we need switches? Why do we need routers? What are the components that they utilize? What are the terms? What are the different aspects of each technology? How do they work with each other? And if you are taught correctly, you are taught from a bottom-up approach. So we take a look at the theory first, talk about what is TCP/IP, what is the OSI model, what is an IP address, what is a MAC address. And then we start bringing the fundamentals into play and start correlating it to different portions of Cisco IOS, or the Internet Networking Operating System. And we start breaking these pieces down so that you, the learner, can take that information and then utilize it for future studies and use it as a building block to build your networking skill set. So CCNA, in most cases, is referred to as an entry-level certification, like I mentioned already. However, I don't look at it at that perspective when it comes to people that I work with that have it, because all the certification does is it basically tells me that you took and passed a test, and I'm like, okay, cool. Basically, the certification is to test a minimally qualified candidate. That is all. There's no like, there's no parade when you pass. I mean, you're gonna feel good about it, yes, but there's no like, Macy's Day Parade or the 4th of July. I'm in the U.S., so for those of you that are not familiar with those terms, there's no big celebration when you pass unless people are make a big deal about it. So it basically just validates that you are a minimally qualified candidate that was able to pass the exam and move from there. So as you're moving forward in your career and you're going after CCNA, there's a couple of major things you need to worry about. And I'm going to first start off with the exam dates and what that means and your time frames and stuff like that. So as it sits right now, you will be able to test, let's see here, from version 2 to version 3. Candidates can choose to take either version 2 or version 3. The last day to test version 2 will be August 20th, and the last day to test, that's for CCNA. This is right here. This number right here is the composite exam. Right? This is the composite exam, and this guy right here is the ICND 1 exam. Now, the reason why I say this is a composite, the composite is actually a combination of both ICND 1 and ICND 2, basically mushed together, and they deliver that to you as your exam. It's oftentimes a way for somebody that has got time in the field, has done this stuff for a long time, that knows the theory, knows how IP routing works, knows how switching works, knows how the OSI model works. They're not coming at this from like you have no experience at all, you have no theoretical understanding. You already know what's up, and you can go take this exam, and passing it earns you a CCNA. Now, for those of you that are coming with no experience, no understanding, no theory, no implementation experience, the 100-101 ICND1 version 2 exam, that is going to be basically your introduction to networking in the Cisco space. Then you have the 200-101. This is ICND2. If you take and you pass this exam right here and this exam right here, what does that earn you? A CCNA. Take both exams, you get one certification. But if you take and pass this exam, you earn the Cisco Certified Entry-Level Networking Technician, or the CCENT. So basically, you really can't get any lower in certification than that, other than like the Cisco Certified Technician, which doesn't really even qualify. And then you go take and pass this exam. This basically is the exam you need to pass the CCNA with. I approached it from the 2 exam route because I came in with no networking experience whatsoever. I needed somebody to help me get through all that stuff. Now, I work with an individual who's actually been doing networking for probably the past 5 years, and he's really good at what he does. So he's going for the CCNA exam. Why do we need to make him go through ICND1 when he already knows all that stuff? So that's what he's doing. So September 24th is the last day you can test on that. Now, when it comes to prerequisites, there are none. You can come in off the street and go take this test, assuming you've already paid for it. So you would pay for that through a Pearson VUE Testing Center. I don't know how it works outside of the States. I just know what our options here locally. Now, yeah, the required exam, this right here is going to be the CCNA composite. They call it accelerated, which actually makes a lot of sense. Because you're basically taking both exams and you're saying, I already know what I'm doing, just give me the test. That's more of a design for those that already have a CCNA, like myself, that could go in and recertify. And then you have the ICND1 exam. So they're basically renumbering, and the 100-105 and Interconnecting Cisco Networking Devices Part 1. So a lot of theory. And I'll cover the blueprints for each one here in just a moment. Then you have ICND2. You pass ICND1 and ICND2, you earn a CCNA. Simple as that. And they are the exact same cost. So this one's usually $150. This usually is $150 US. And together they cost $300. If you go take the CCNA, it's $300. So for those of you that are on a budget and can't afford to drop $300 on an exam, that is a lot of money. Even for myself, that's a lot of money. Typically people like to take the 2 exam route because then it's easier to digest financially. And I completely get that. If you are fortunate enough to have an employer pay for it, or you have some other means, regardless of what that is, take advantage of it. I know I did. So that gives you an idea of the background behind that. Now, I will put this link in the description so you're able to click in here and whatnot. I've actually got the PDFs already set up for each one of these exams. I'm going to walk you through both ICND 1, ICND 2, and then the composite. And we're going to talk about the new topics that are out there. I'm going to spend a few minutes on each one so you have a general idea as to what's going on and you're not like completely baffled. So, for Interconnecting Cisco Network Devices Part 1, or the 100-105, it is a 90-minute 45 to 55 question exam. So what this basically means is in that 90 minutes, you're going to get between 45 and 55 multiple choice questions. There might be a couple of interactive type exam questions where you have to actually like configure something, where they might say, okay, enable RIP, the routing information protocol, on this router, and enable that enable it to send traffic out this interface. Something very, very basic, or configure an IP address on this interface. It'll likely be very simple things. So be aware of that. They actually, I believe they have a, I don't know where it's at here. When I get towards the end of the video, I will try to remember to see if I can find the exam demo. But there's it right here. I'm not sure if they have a. They might be on the Cisco Learning Network side, and I'll take a look at that here in a moment. So when you are talking ICD-1, so this is basically you have no experience whatsoever. That's the one way you can categorize it. 20% of your exam, and that's one of the things nice Cisco does, is they automatically come in here and they give you a percentage of how much of the exam you could be tested on at this level. So first and foremost, they're going to test you on a lot of theory. Compare and contrast the OSI and TCP/IP models. So do you understand the different layers to the network stack? Do you know the difference between the physical layer, the data link layer, the network layer, the transport layer, the session layer, the presentation layer, and the application layer? If you know all that, you're in really good shape out of the gate. So you also have compare and contrast TCP versus UDP. TCP is a unicast type of connection, so from you to somebody else. UDP is typically going to be a multicast or a broadcast. So like for instance, if you're watching this video, this is considered to be a broadcast. It technically is not. It's actually a unicast connection between YouTube and yourself. But broadcast is typically voice and video because of the fact that it's UDP transmission. UDP is connectionless, meaning that I'm just going to send the traffic. I don't know if you get it or not. TCP, there's always a SYN and an accent. So when I send traffic back, I get an acknowledgement back and say, yep, I got, this is how much you sent me, and I'm ready for more. If that doesn't match, if that matches up with what you sent them, and they send you a response saying, okay, this is what I got, and that matches what you sent them, then you know everything is good. And then you go back and forth. Describe the impact of infrastructure components in an enterprise network. So firewalls, access points, wireless controllers. These are infrastructure components. So one thing that you're going to find throughout your networking career is you will likely have to know some level of security and some level of wireless. So my advice to any of you that are looking to break into the networking industry is, especially if you want to be an infrastructure engineer like myself, your best bet is to get CCNA routing and switching, make a left-hand turn into CCNA security. Go learn security. Go learn, how encryption works, how authentication works, how ASA works, how firepower works. You don't need to be an expert in this stuff. You just have to have a general understanding. Go take CCNA security. Then, once you're a CCNA security, make a right-hand turn. Go into wireless so that you'll understand how RF works and things like that, and you'll understand the difference between a standalone access point and or an autonomous access point versus a controller-based access point, and how the different aspects of that would work. And then, if you're so inclined, make another right-hand turn into data center. Data center is huge right now. I can't tell you how many times that I've even when I'm interviewing for positions, or I'm in the network that I work in, we have a pretty large, robust data center. data center is huge, so understanding how a Nexus and UCS work will be very, very beneficial in your career. Believe me when I tell you that. So those are some areas there. And then once you have a good base, 2, 3, 4 CCNAs, I know that's a lot of material to cover, and if you're brand new, believe me when I tell you, it's better to have a little bit wider of a base when you start, because then you're going to be more familiar with things than that. I didn't do that when I first got started. I went CCNA route switch, CCNP route switch. Then I made a left-hand turn into CCNA security. Then I went after my CCIE in routing and switching, and then I stopped. I just recently picked up CCNA wireless, and I am actually studying service provider right now. So it's kind of a unique bag, but the more you can pack in and the more knowledge you have, the better off you're going to be. So you're going to have to deal with a collapsed core versus a 3-tiered architecture and understand what that means, where instead of having 3 tiers where you have your core, distribution, and access, your core and your distribution are the same devices. So that's the difference between a collapsed core and a 3-tier architecture. Compare and contrast network topology, star, mesh, and hybrid. You know, are all of your devices directly connected to each other? Are they in a mesh? Are they, all devices connected to one central device as a star, or is it a combination of both? Or are you a partial mesh, where everything's connected to each other, and then you have some direct point-to-point connections between devices? Cabling type based on implementation requirements. Are you using fiber optic cable in the correct way? Are you trying to interconnect switches between each other with crossover cables? Different things like that. Troubleshooting methodologies to resolve problems. You'll find that you really can't troubleshoot something unless you really know how it works. I can't tell you how many times where I have been tossed problems simply for the fact that I'm a senior level engineer. That's just my title at work. I'm a senior level engineer, and I'm tossed a problem, and I know nothing about that platform. So I have to spend a whole bunch of time learning the platform, learning how things work, learning the technology, learning the implementation, learning the design, so that I can go back and say, okay, based off what I know, what's not working? And then I can try to figure it out from there. You can't teach troubleshooting, because you can't teach troubleshooting if the person you're teaching doesn't know how the protocol works. Simple as that. And if anybody says otherwise, I'm going to call them out and say that's the biggest load of BS ever. Because if you don't know how something works, how are you going to troubleshoot it? If your car won't start, there's several different things I would check. Is it got gas in it? Is the battery good? Is the spark plugs intact? Is the alternator in place? There's all my connections good? Did my my computer go out? I mean, there's several things that I'm going to check before I'm, but if I didn't know that, I wouldn't know what to look for. So you have to understand how the general networking works before you can troubleshoot it. And that comes with time. So the more and more you understand, the better a troubleshooter you will become. I'm a pretty good troubleshooter, mainly for the fact that I know how things work. I know how to get things operational. I can look at configuration and go, okay, you're missing a piece there, and if you throw this command in there, that should make it work. But it's because I know how things work. From one thing I recommend people do is they go in and they build something to where it works, and then they break it systematically. You break it at every level you've implemented it at. This way here, as you're breaking it, you can see, okay, if I disable this piece when I know this piece is needed to make it work, what's the output look like? What is that going to look like from a show command or debug perspective? And then if I see that, I can go, okay, well, if I see this error, I know that this potentially is the problem. So you're correlating issue to problem. You find the issue, you've there found the problem. Wise men once said that a problem well understood is already half solved. Because if you can identify the problem, you're very, very likely to already know what the problem is. And then you can go in and say, okay, well, in this case here, it's a configuration issue or lack thereof. Maybe they didn't put the config in or they configured it incorrectly. And you have to go in there and tweak it. If you know how to correlate between the two, you are that much better off as a troubleshooter. And then you'll see how subnetting will be a huge portion of that, because even today, subnetting is something that I'd have to deal with, with allocating, addressing to things, and spinning up new stores or spinning up new locations or adding users or adding desks and laptops and access points and servers and stuff like that. You're going to be dealing with addressing for the rest of your life. You might as well get really good at it. Compare and contrast IPv4 addresses. There are 3 types. I'm not really going to go into too much detail on that, but you'll definitely have to understand IPv4, which ties into addressing and subnetting. IPv6 is going to be a huge portion of the exam, and quite frankly, IPv6 is one of my favorite topics. Now, IPv6 is actually very, very easy if you have a solid foundation of IPv4. Don't try to learn IPv6 if you don't know IPv4 already. There's so many correlations between the two that it will make learning, put the time and effort in the IPv4 first, and then start learning, what's there between global unicast and unique local, then link local, then multicast, and then modified EUI64. Start learning IPv6 piece by piece by piece. And eventually you'll be like, okay, I know the different address types, I know what each one does, I know what stateless address auto configuration is, or SLAC, I know what stateful address configuration is, or commonly referred to as DHCP v6, and you'll be able to take that information and run with it. You'll be that much better off with it. So when it comes to LAN switching fundamentals, this is going to be a quarter of your exam, so almost half your exam is already chewed up now. Between your network fundamentals and your core LAN switching, that is half your exam already out of the gate. So you're going to learn what it is for MAC learning and aging, frame switching, frame flooding, MAC address tables. You're going to learn what switching is. Switching, in the grand scheme of things, is identical to routing, where you route based off of where you're trying to get to. So you look at the destination and you figure out how to get there. So there will be definitely multiple aspects of how to look at that. There is you'll definitely take a look at spanning tree protocol. I'm not sure if you're going to see that in here. Let's see, do they have spanning tree? It doesn't look like they have spanning tree. What they really want, what it looks like to me that they want you to learn here is the core LAN. What I mean by core LAN is, what's a VLAN? What's a trunk? What's .1Q encapsulation? What is CDP? What does a MAC address do? How does the switch flood and learn MAC addresses? If there's an unknown broadcast MAC address, how does it handle that? What is the end goal of what you're trying to do? So things like ARP and trying to figure out, what the destination MAC address is. If you know the IP, if you don't know the MAC, you have to go use ARP. And they have access ports and data VLANs. For data and voice VLANs. Both actually can be tied to it. So that's the only time you'll ever be able to see both a data and a voice VLAN, 2 different VLANs placed on the same interface. It's the only time you'll ever see that. For an access port, there are ways of doing that inside like the service provider network, to basically have a link come across from the service provider to the customer edge and have run 2 VLANs across that link. But that's a little bit different. The default VLAN is VLAN 1 on switches, so just be aware of that. They have CDP and LLDP. CDP is Cisco proprietary. However, I have seen multiple vendors like HP and who was it? Just HP, as far as I know, that utilize CDP. There is LLDP, which is the Link Layer Discovery Protocol. Pretty cool protocol as well, but it's one of those things where it just does pretty much the same thing that CDP does, except for it's vendor agnostic, which means anybody can use it. Then you have configure, verify, and troubleshoot port security. You can go in and statically assign a MAC address. You can dynamically learn a MAC address. You can dynamically learn a MAC address and then save it to the running config with the sticky command. You can configure the maximum amount of MAC addresses on a per interface basis. If there's a violation of a security profile, how do you handle that? Do you shut down the port? Do you not shut down the port and let somebody know about it? And if there is a violation, how do you recover from that violation? Do you wait 5 minutes to try to bring that interface back up? And then we have routing fundamentals. You're going to understand how a packet is handled throughout the network and what exactly is done throughout the when a packet comes in on an interface, what the process is. And from a high-level overview, when a packet comes in the interface, the layer 2 header is ripped off. The layer 3 header is referenced. is the destination IP an IP address that I have configured locally? If yes, great, then you know it's destined for that router or that device. If not, consult the routing table. Figure out what in the routing table where that traffic is supposed to go. If there's no match in the routing table, whether it's a default route or a longer match, drop the traffic. If there is a match in the routing table, great. Then what do we do there? We go ahead and we try to figure out what interface do we switch the packet towards in order to send that traffic on its way. So we move from interface 1 to interface 2, and then we rewrite the layer 2 header and send the packet on its way. We'll take a look at the difference between a prefix, which is the actual subnet you're trying to reach, the network mask, the next hop, routing protocol code, administrative distance, metric, gateway of last resort. So there's definitely several things that you need to understand about routing in order for this to all work. And they'll talk about the administrative distance. You know, how do you choose one routing protocol over the other? And a better administrative distance wins. It's more believable. So administrative distance really just means if I have 3 people telling me the same thing, which one's got the lower administrative distance? That's who I want to believe. So if you have a really high AD, that guy is probably lying to you. So it's a way to determine, you know, which suspect is telling you the more accurate truth. It's a bad example, but it's what I'm going with. Well, we discussed a couple minutes ago about VLANs. And if you don't know what a VLAN is, it's basically a layer 2 segmentation of a switch. And it allows you to break up a switch into multiple broadcast domains. Well, in order to get from broadcast domain 1 to broadcast domain 2, you need to be able to route in between those. Well, that doesn't happen by default. So unless you have a layer 3 device, whether it's a layer 3 switch, a router, in this case router on a stick, which means a router that's got multiple sub-interfaces on it, or it's a firewall that does the exact same thing that a router can do, you need to be able to route in between your VLANs. So in order to do that, you need to have a layer 3 device. And router on a stick is one of the options for that. We'll take a look at static routing and dynamic routing. Static routing is good for very, very small networks. So if you had just a couple of routers and maybe a switch or 2 behind that, you don't need dynamic routing. Unless you have a need for it, like maybe if, for instance, you're connecting via MPLS BGP, you might need to connect via BGP to the MPLS network and get some routes that way, if it makes sense. But if you're just doing it to do it, typically speaking, a static route gets the job done if the network is very, very small. And then you have both IPv4 and IPv6 static routing. There's definitely each default route is how you get to the internet. If you don't have a better match, use me. Basically what a default route does. A network route is a more specific route. How do I get from where I'm at to where I want to go? If I want to get from here to Walmart, there is a few streets that I have to travel on to get there. That's what a network route is designed to do. A host route, it points to a specific computer. A floating static route is like a default route or a network route or a host route with a higher administrative distance. So it does not get injected in the routing table right away unless the route that you want to take is lost for some reason. And then the floating static route will take over and act as like a backup or a high availability capability that you can implement. And then you have RIP version 2. We'll take a look at RIP version 2. RIP version 2 is actually very, very easy to work with. So they're only talking about RIP for IPv4. So you won't have to take a look at RIP-NG, which is actually IPv6. And excluding authentication, filtering, manual summarization, and redistribution. So literally all they're doing is making you go in and turning it on. There's really not a whole lot more to it than that. That's pretty much it. There is a lot to RIP, not compared to the other routing protocols, but there is several things that you need to be aware of. But RIP, in the grand scheme of things, is very, very easy to work with. And then you have infrastructure services like, let's see, I'm not sure how much farther down it goes. Okay, not too much far. DNS, you know, DNS is going to be one of those things where you're going to want to, instead of ping by IP, ping by name. And then configure, DNS is not very difficult to get working, you just have to know what you're doing. And that's relatively simple to do. IP domain lookup is going to help you out with that. Having a DNS server that you can call out to would definitely help. You can actually manually configure static DNS entries in your routers and your switches, as long as it's a layer 3 switch. So I can say I want to ping my wife's computer from here, and I ping in, say, you know, Chimney Cricket, and boom, I get a response. Configure and verify DHCP on a router, excluding static reservations. So configure the server to actually hand out addresses. Configure the client to the router to be a client to receive an IP address, which is very common. TFTP, DNS, and gateway options, and configure the relay. So DHCP works in two different ways. You've got the DHCP server that's local to your network, so in the same subnet that you belong to, and you have DHCP where it's not on the same subnet as you. If DHCP is not on the same subnet as you, you would simply just send out a DHCP discover, and that DHCP server will receive that traffic. It'd be the same thing as if a computer on a LAN segment is connected to a router, that router is going to receive that DHCP discover message and start going through the offer, the request, and the acknowledgement phase in order to actually hand out an address. You would use the helper address in order to basically take that local broadcast message for DHCP and send it to a remote network to try to get DHCP in. And then there's some connectivity issues and whatnot. Then there's NTP, Network Time Protocol, to verify the time. And then you also have ACLs, standard and named access lists for routed interfaces. This is going to be for filtering traffic. Now ACLs are going to be something you use in the data plane. So if you want to block web traffic, if you want to prevent somebody from telnetting to your router, or somebody from, being able to send to whatever in the data plane, it's always going to be something in the data plane. Where a prefix list is a control plane filter. It is going to help you mitigate based off of prefix list and things like that, and who the route is and what the match is. And then we have NAT. NAT is going to be how you go from a private address to a public address. So you're going to do what they call network address translation. So you can do a static entry. So if you've got a resource internally that you need people from the outside to be able to utilize, then you can put in a static NAT entry in. That's actually how I get a remote desktop into my home from the outside. So I plug in my public IP address and I hit the enter key, and it pulls up my computer. I type in my information, and boom, I have access to my computer that I'm recording on. You have a pool where you can pull from a pool of addresses, and then you can map certain one public IP to multiple ports or multiple services. So remote desktop, web services, DNS, whatever, all kinds of options. And then you have infrastructure maintenance. So you have doing your logging and licensing and time zone. So these are device management. These are going to be very, very large, and especially for day-to-day operations is where this mostly falls into. The initial device configuration. If you just got the box in, how do you set it up with a basic configuration so that you can get out of the data center and go back to your desk and continue configuring it? And then we have device hardening, which is going to be how do you prevent people from accessing it that don't belong on that device. Whether it's, in this case here, they're talking about local authentication. So you have Telnet and SSH login banner, so putting some legal information if you don't belong here, what can happen to you. And then they have device maintenance where you're doing upgrades and using verifying the MD5 hash on the checksum to make sure that there hasn't been the iOS code was compromised in transport when you're downloading it, recovering the password, and then making sure you understand the file system so you know how to save things and whatnot. And then you have a couple of other commands in here where you're doing pings and traces to make sure you can actually get to where you're going. Because just because you ping it doesn't mean you're taking the path that you want to take it on. And logging events. Now that's pretty much ICND 1. There is quite a few things in there. It's definitely a lot, but I wanted to kind of go over a high-level overview of some of the topics. Now when it comes to ICND 2, there is a mixed bag of topics on here that they're basically taking what you already know in CCNA or in ICND 1 and expounding on those. So you're going to talk about some of the same things, but you're taking it to the next level. You're going deeper. And, excuse me, so access ports, setting up data and voice on the same port, different VLANs, we'll talk about DTP and VTP version 1 and 2. You know, how do you dynamically negotiate a trunk link, things like that. Then we get into spanning tree protocol. You know, regular spanning tree and then rapid spanning tree, and what the differences between the two are. If you've got redundant links between your switches, how does that work? Spanning tree is a pretty straightforward protocol to understand. A lot of people hate it because they don't understand it. Then you have some enhanced features like port fast. So how do you basically disable the listening and learning and go right into forwarding? And if you have a switch attached to your, let's say for instance, a port is supposed to be connected to a computer and as an access port, how do you prevent that port from connecting to a some user brings in like a little 8-port switch from home and plugs it in so they can add more devices? Well, BPDU guard would help mitigate that, because if a BPDU is detected on that port, by default it's going to shut it down. And then you have ether channels. So one way that you could help optimize spanning tree protocol is by basically fooling spanning tree into thinking that 2 links between 2 switches actually look like one. So you would do that with ether channeling. You could do it statically by just turning the protocol on, or the feature on, or you have the Cisco proprietary way of PAGP, or the port aggregation protocol, or you can do it the open standard way, which is the LACP, or the link aggregation control protocol. Either way will work. It's up to you on how you want to do that, but the key factor here is both are layer 2 and layer 3. So you can do just a layer 2 trunk, or it could be a routed interface to where it actually participates in routing. You have switch stacking and chassis aggregation. So for instance, if you have a 3750 or the 3850 or the 2960, all of those switch models have the ability of what they call switch stacking, which simply means you have 2 or more switches that are physically connected to each other through what they call a stacking cable. That stacking cable simply acts as a backplane extender between the 2 switches. So for instance, if you are out there and most common networks run the 3700 platform to do that. So I can go out, put a stacking cable. As a matter of fact, to my left here, I have 2 3750s, and they are stack-wise together. So 2 switches appear as one from a logical perspective. When you log into it, you see 2 switches. Once it's provisioned, you're good to go. There is another version of that with like the 6500 chassis switches, what they call the virtual switching system, or VSS. Same concept, except for the fact that you're not doing a special cable, you're running what they call a VSL, a virtual switch link, and what that does is it synchronizes the control plane between the 2 switches so that they appear as one device. You also have, in Nexus, you have VPC, or virtual port channel. Same concept, except for there's a little bit of a difference between the control plane is split, where you are making multiple switches look like one. Then you have chassis aggregation, which basically is switch stacking is the 3700s, where you are stacking together, and then you have chassis aggregation, where you're taking like the 6500s or the Nexus switching platform, and you're making multiple switches appear as one device. So very cool stuff. Common threat access layer threat mitigation, .1x, for basically per device authentication to the network. You have DHCP snooping, preventing somebody from handing out IP addresses that doesn't belong doing that. You have the non-default native VLAN. By default, the native VLAN is 1, and it by default is untagged, which means that's what indicates it's native. There's no .1Q identification in the header. There's the .1Q tag is there, but there's no numerical value inside of it. So therefore, it is a non-zero, which means it's native. If you change that to say 10, then that changes the native VLAN to 10. So some of your routing technologies, you're going to deal with taking intra-VLAN routing to the next level with, again, router on a stick, where you have a router with a connection down to a switch, and you configure multiple sub-interfaces on that switch that are going to listen to a certain .1Q header. So that's how you do intra-VLAN routing from a switch. On an SPI, or I'm sorry, on a router. And if you have an SPI, a switch virtual interface, basically you're going to configure an interface on that switch in that VLAN, and then enable IP routing, so you'll be able to route between your VLANs. Distance vector and link state, RIP and EIGRP are distance vector routing protocols. because they only know what their next directly connected neighbors tell them about. Link state routing protocols like OSPF and ISIS, we won't touch on ISIS. OSPF is a link state routing protocol. It's an open standard, which means any vendor can run it. Same with RIP. RIP is open standard as well. So you can go in here and you can take OSPF and run it all day long. Very easy protocol to get working. And there's a compare and contrast interior and exterior routing protocols. They do bring BGP into CCNA part or ICND2. In OSPF, they only talk about IPv4 and IPv6, which are actually two different protocols. So if you try to run OSPF version 2, OSPF version 2 IPv4 with OSPF v3 IPv4, it will not work. So they are wanting you to run OSPF version 2 for IPv4 and OSPF v3 for IPv6. This will work all day long because there's two different protocols running two different address families. So basically what they're doing is with both of these, they're excluding authentication, filtering, manual serverization, redistribution, stub, virtual link, and LSAs. So what they're really doing is turn the routing process on, throw a network statement in there, and that is it. They are literally pulling everything back that you potentially would need to know. And they're saving that for CCNP. So basically they are taking all the fun from OSPF out. There's so much you can do with OSPF. And they're actually doing the same thing with EIGRP for both V4 and V6. And if you'll notice, there is everything that you're going to study from here on out pretty much is going to be both V4 and V6. So be prepared to know both. That's why they have you study in ICD1, V4, and V6 for the address family itself. You know, the IP basics and stuff like that. They don't talk on RIP-NG. They might in future places. RIP-NG, a little bit different of a deployment method than RIP is, where you do everything at the interface level instead of doing everything at the process level. But at the grand scheme of things, it's very, very easy to work with. They are literally handicapping you on everything with EIGRP. They basically just want you to turn it on. Router EIGRP1, throw a network command in there, and you're done. And that's pretty much it. They've taken everything else out. WAN technologies. Configure and verify PPP, multi-link PPP on WAN interfaces using local authentication. PPP is the point-to-point protocol. It's layer 2 connectivity between two devices on a serial link. Multi-link PPP is where you're taking two independent PPP circuits, maybe two T1s, and you're basically bundling them together to make it look like one. So instead of having two 1.5 meg circuits, you've got one 3 meg circuit. I configure and verify PPPoE client-side interfaces using local authentication. Basically what they're having you do here is try to run DSL. So it's really hard to grasp the concept here because normally, for instance, with a provider, they're going to give you the PPPoE configuration, and what they're going to do is they're going to give you a username and password to type in on the client side, and that's it. So you're going to say you're going to click on PPPoE, you're going to type in some specifics to the provider and a username and password. That information is going to be received by the provider. It's going to be authenticated on their side and then dropped off back to you with an IP address and some routing information, and voila. Anytime I do this configuration, I do both the server and the client so you guys can see both. It's kind of the same thing with PPP here. It's really not beneficial just to see the client side, but from a enterprise perspective, you're not going to be configuring the provider routers. You're only going to be configuring your routers, but it's important to still see the process. It makes more sense in my opinion. Configure and verify troubleshooting GRE tunnel connectivity. GRE is stupid simple. Basically just a tunnel. It makes something that's multiple hops away look like they're directly connected. GRE is very, very easy to work with. Turn it on and let it go. GRE gives you a lot of flexibility in some environments, like if you're running IPsec VPN between multiple sites. IPsec by default only allows unicast, which if you did not know about the unicast capability in all the routing protocols using the neighbor statement, you probably wouldn't be able to get it working. Where the GRE tunnel allows you to take that configuration and move it that much better. It supports multicast. That's one of the big things. Describe WAN topology options. Point to point, I'm trying to get from Milwaukee to Chicago. Hub and spoke, I've got an office in Milwaukee, an office in Chicago, an office in Indianapolis, an office in Miami, and I want to be able to talk to all three of them. That's hub and spoke. Full mesh is Milwaukee, Chicago, Indianapolis, and Miami all can talk to each other. It doesn't matter which way you go. Single versus dual homed. Single homed means you have one connection going to the provider. That's it. Dual homed means you have two connections going to the same provider. You have multi-homed, which means that you have at least one connection going to two different providers. Then you have dual multi-homed, which means you have two connections going to each provider. And that allows you to have that WAN high availability. Describe WAN access connection options. Technically speaking, all of these right here, this guy here, has absolutely nothing to do with your physical connection to the provider. MPLS is a transport connection inside of the service provider network. It has nothing to do with you actually connecting to the provider. MPLS is on the back end that you don't see. Metro Ethernet, broadband PPPoE, and Internet VPN, DVPN, site-to-site VPN, and client VPN. Those are all connectivity. Those are all transports that you would utilize to get to it. So they are literal circuits that you would use to get to the provider network. So MPLS is in the backbone of the service provider core. So MPLS L3 VPN, if you will. Then you have Metro Ethernet, which is typically fiber optic cable or an Ethernet circuit that's dropped off into your network to provide layer 2 connectivity. You have broadband PPPoE, which basically is the same thing as PPPoE that we just talked about up here. So this is the, what is PPPoE? The point-to-point protocol over Ethernet. And then you have Internet VPN. DMVPN, or Dynamic Virtual Private Network, utilizes multi-point GRE, and in order to facilitate, instead of having a tunnel from Milwaukee to Chicago, Milwaukee to Indianapolis, Milwaukee to Miami, you have one tunnel and all these different, you configure the GRE tunnel and you use a protocol known as the Next Top Resolution Protocol, or NHRP. DMVPN is actually a routing technique, not a security feature. So you would get DMVPN up and running, and then you would overlay like IPsec VPN on top of it. And so they work together, but they're mutually exclusive. You could run one without the other, or together as a pair, and they both work great together. And then you have site-to-site VPN, and setting that up is actually really simple. That could be considered to be just a GRE tunnel. A GRE tunnel from Milwaukee to Chicago, that is a site-to-site VPN, because you are isolating traffic from your internet connection that would be publicly routed over the internet, that is encapsulated inside of a tunnel that is tunneled over the internet to wherever you're trying to go. So typically GRE, it's clear text though. Site-to-site VPN, this is encrypted. And then you have client VPN. How do you connect from where you're at to the headquarters? Are you doing remote access with like AnyConnect, or are you doing something like the regular IPsec VPN client? Configure and verify single-homed branch connectivity using eBGP IPv4, limited to peering and route advertisement using network command only. This is the first time I've ever seen a CCNA course talk about BGP. Now, BGP, in the grand scheme of things, is a massive protocol. Absolutely ridiculously large topic area. I could easily do 50 videos on half an hour or greater on all of the different things you can do with BGP. Because BGP is not just the internet routing protocol, it also is the protocol that you use for MPLS VPN, that you can use with your layer 2 VPNs, with inside of the data center. It is a very, very robust protocol. So with them having you just form the peering and advertising a route, that is literally the most basic configuration you could possibly handle with BGP. There's so much more to it than just that. But it makes sense for those of you that are on maybe network operations that need to know how this stuff works. That is a great place for you to understand, is basic BGP. Then they have some infrastructure services, HSRP, hot standby routing protocol. What that guy does is, or router protocol, I'm sure somebody heard me and they're going to say, it's not routing, it's router. Whatever, you get the point. Basically allows you to have two devices handing out the same IP and MAC combination for the default gateway. So instead of you having, say, a 6500 here and a 6500 here, and if this guy goes down, then MAC address flooding and it has to happen, and then you have to learn about this guy. If these guys are both talking HSRP in the same subnets, this guy could be your primary default router, and then if this guy goes down, this guy will immediately take over for it. Very cool protocol. Describe the effects of cloud resources on enterprise network architecture. So, traffic path to internal and external cloud services, basic virtual network infrastructure, and virtual services. It really depends on where you're going. If you're dealing with like AWS, you can set up a VPN between your location and them, and then you can go in and connect into their instances and stuff like that and create virtual devices and all kinds of cool stuff. There's so many different ways that can go. I'm not really going to go into detail on it. Describe basic QoS. Marking the traffic. Did you mark your voice traffic to be, EF or expedited forwarding? Do you trust the device? Prioritization, voice, video, data. Shaping the traffic. How are you slowing it down or placing? Are you dropping it? How are you managing the congestion? QoS is a very deep topic. So it's one of those things where it's very difficult for me just to sit there and go high-level review on it because of the fact that there's so much to it. And then they have configure, verify, and troubleshoot IPv4 access lists and v6 ACLs. You have the standard ACL, which matches based off of the source. You have the extended ACL, which matches based off the source, destination, the protocol, and the port. And you have names, which basically replaces the number with the name, so it's makes more sense. Verifying ACLs using the APIC EM trace path ACL analysis tool. I know nothing about APIC. Other than the fact that it's used in ACI for software-defined networking. I'm not going to go any further in detail on that. To be honest with you, this section right here is 14% of your exam. If, for whatever reason, you decided not to learn this piece right here, and you do well in other areas of the exam, the likelihood of you failing the exam based off of you not knowing that, slim to none. To be honest with you, when I have to go study for my CCIE written exam to recertify my CCIE, 10% of the exam is going to be based off of emerging technologies. I'm not even going to bother covering them. Because the other 90% of the exam, I am sure I will have no problem utilizing that information to pass the test. I quite frankly don't care. To me, SDN and all these other features, Cisco's ACI product line, things like that, they are too new and stuff like that in order to be really utilized. I think Cisco has somewhere in the neighborhood of between 200 and 300 customers that are running ACI with APIC, or however they're deploying it. I think the technology is too new and hasn't been properly vetted. Now, if you want to talk about VMware's NSX, I think that's a technology that's worth talking about because I've seen it stood up, I've seen it deployed, it works quite well. ACI still needs to go through the growing pains. It still needs to be developed. It still needs to be built out. I think it's too new. That's just my opinion on it. I've never seen it deployed, but from what I've heard about it, Cisco will sell it to you very, very cheap. I know companies that have bought 9Ks, Nexus 9Ks, to deploy ACI, and everything works out quite well with it, with getting the 9K deployed and things like that. But I hear, just word of mouth, that ACI doesn't always work quite the way that it's sold. Then again, I haven't seen it firsthand. I'm just going up based off what I've been told. So take that as you will. I'm just stating here from a percentages perspective in the grand scheme of the exam. Chances are, if you were asked about APIC EM, don't not go in there and study it. I have absolutely no issues with you guys going in there and learning a little bit about it. If you're interested in learning about SDN, go for it. But if you're like, if you asked me, I wouldn't waste my time. It's too new. It needs time to be developed and to be production approved, things like that. It needs time in the field. Doesn't say that it isn't cool, but I think Cisco's version of SDN needs a lot of improvement. And then you have infrastructure maintenance. You know, SNMP version 2 and version 3 for monitoring. Definitely know how that type of stuff works. It's very easy to get working, but important to know. And then just the troubleshoot network connectivity issues using ICP echo-based IPSLA. So basically, if you're wanting to have some sort of high availability in play, you can actually configure an IPSLA to ping a specific IP address on a regular interval, and you attach that. You configure what they call a tracking object to monitor the SLA, and you would then use that tracking object, and you would say you would append at the very end of the configuration that tracking option to the end of a static route. Let's say you have a default route to your primary path, and you have another static route pointing towards your backup path. On your primary path, you would append the tracking object towards that. So if, for instance, if you can't ping Google anymore and the traffic goes down, then what will end up happening is if the IPSLA fails, tracking object fails, therefore the default route, the primary default route, gets removed from the routing table, and then the other default route you have configured gets injected, and then away you go. And then from there, using local span to troubleshoot and resolve problems. Basically what you're doing here is you are capturing the traffic and you're sending it to like a wire share capture to analyze what's going on. Very good idea. You don't have to do that with every platform. That's more of a layer 2 thing. Normally I like to use the in the CSRs or the ASR1K, I like to use the embedded packet capture feature. Does the same thing. Device management using AAA with TACX and Radius. Know what AAA is. No, TACX is proprietary to Cisco, and Radius is open source. Describe network programmability in enterprise network architecture. Functions of a controller. Now, this is SDN as well. I would say spend a little bit of time in this. This other one up here, that is just a verification. I don't care if you don't put any time in this. This one will be a little bit more involved. Now, this one here, just understand what that is. Now, if you understand what PFR or performance routing is, basically Cisco's first attempt at SDN, spend a little bit of time on that, because it's actually kind of cool having a master controller tell some border routers what to do. So the same kind of idea happens here with like VMware with vCenter, where you have all of these ESXi hosts that are joined to vCenter, or consider and vCenter manages the hosts from vCenter, or consider a wireless LAN controller to a bunch of access points. The same concept applies. Or ASDM to ASA. They all pretty much do the same thing. They are all a controller that manages one or more devices. So from that perspective, that's important to know, because especially in larger networks, you're probably not going to be managing devices on a per device basis. You're probably going to be managing them from a centralized single pane of glass from like SolarWinds or your LAN controller or what have you. Or if you're dealing with UCS Central, if you've got multiple UCS clusters with the B5108 and the fabric interconnects, things like that, those are things that you would want to have a single pane of glass, because networks grow very, very rapidly. Troubleshoot layer 3 end-to-end connectivities. Those are going to be things that you're going to need to understand how traceroute works. Like I mentioned a couple minutes ago, just because you can ping it doesn't mean you're actually going to be taking the correct path towards it. So once you can reach it, are you taking the correct path towards it? If not, figure out how. That is pretty much it. Basically, this guy right here is a combination of both. This one's 7 pages, so basically they just brought together everything in one fell swoop. They're going to talk about the different technologies and whatnot. So just know what they are at the end of the day. That's pretty much where it boils down to. Just know what they are and how to work with them. That's really CCNA. I want to thank everybody for stopping by and hanging out for a little while. Information is always good to have. Like I said, I've received a lot of requests for updates and whatnot, and so I figured, you know what? I'll go ahead and just shoot a quick video on how this stuff will work and some of the things you need to be aware of. Until next time, you guys take it easy. Have fun. Don't get discouraged. If you do, drop me a line in the comments. I'm always here to help. Until next time, take it easy, guys.